Hello GATE aspirants, welcome to part 10 of GATE solid state physics series. Question number 1. The relative magnetic permeability of type 1 superconductor is, for type 1 superconductor, susceptibility is -1 and it is equal to mu r minus 1. That means mu r, that is relative permeability, is 0. So option A is correct. Next question. In order to estimate the specific heat of phonons, the appropriate method to apply would be. So we have two theories for this. One is Debye theory. Now this Debye theory is valid at low temperature, and that is when the medium is non-dispersive. So non-dispersive medium means K is tending to 0, and in that region that will be a caustic branch. And Einstein model is used at high temperature. That means it will be optical branch. So Einstein model for optical phonons and Debye model for acoustic phonons. So option B is correct. Next question. Consider a three-dimensional crystal of n inert gas atoms. The total energy is given by this expression, where r is the nearest neighbor distance between two atoms. The two constants epsilon and r have the dimensions of energy and length respectively. The equilibrium separation between the two nearest neighbor atoms in unit of sigma. For nearest neighbor distance, we can take derivative of this with respect to r. So du by dr is equal to, this is constant 2n epsilon, p into sigma raised to 12, and derivative of r raised to minus 12 is minus 12 upon r raised to 13 minus q into sigma raised to 6, here minus 6 upon r raised to 6. This is equal to 0. So this constant is not equal to 0. That means this term has to be equal to 0. So p into sigma raised to 12 into 12 upon r raised to 13, that will be equal to this 6 into q into sigma raised to 6 upon r raised to 6. So that means 12 by 6 into p by q, sigma raised to 12 upon sigma raised to 6 is equal to r raised to 13 upon r raised to 6. That means 2p by q is equal to sigma raised to 6 is equal to r raised to 6. You can take 6th root on both sides. So r is equal to 2p by q raised to 1 by 6 into sigma. Value of p and q is given. So 2 into p is 12.13 and q is 14.45, whole thing raised to 1 by 6 into sigma. And this comes out to be 1.09 into sigma. So that is r. And the answer range for this question was 1.07 to 1.11. Question number 18. The energy wave vector EK dispersion relation for a particle in two dimensions is E is equal to CK. E is equal to CK, that means K is equal to E by C. That means dk is equal to dE by C. If the density of states dE is proportional to e raised to p, then value of p is. Now density of states, let us write in terms of k first. So rho k dk is equal to L by 2 pi the whole square 2 pi k dk. We can substitute value of k and dk. So L by 2 pi square into 2 pi, k is E by C into dE by C. So this will be L square, 2 pi will cancel out, 2 pi into E by C square into D. So from here we can see that it is proportional to e raised to 1. So P is equal to 1. And answer range for this question is 1 to 1. Question 23. At temperature T Kelvin, the value of Fermi function at an energy 0.5 electron volt above the Fermi energy is 0.01. Then T to the nearest integer is. Now we know Fe is equal to, Fermi function is this, 1 upon 1 plus e raised to e minus ef upon kBt, and its value is given 0.01. So 1 upon. It is at energy 0.5 electron volt above the Fermi level. So that means its difference is given. So e raised to, and this will be 0.5 electron volt upon kBt. 0.01 is 1 by 100. So 100 will be equal to this. So e raised to 0.5 electron volt upon kBt will be equal to 100 minus 1, that is 99. So 0.5 electron volt upon kBt is equal to ln of 99. So that means T is equal to 0.5 electron volt upon kB into ln 99. So T is equal to 0.5 into 1.6 into 10 to the power minus 19. Value of kB is, or you can directly use this value here, 8.62 is given. 1.38 into 10 to the power minus 23 into ln of 99, and this comes out to be 1261.57 Kelvin. So nearest integers will be 1262 Kelvin, and the answer range for this question is 1260 to 1266. So this will be the answer. Question 25. A conventional type 1 superconductor has a critical temperature of 4.7 Kelvin at 0 magnetic field and critical magnetic field of 0.3 Tesla at 0 Kelvin. The critical field in Tesla at 2 Kelvin is. Now here it is given. Critical temperature is 4.7 Kelvin and critical field is H is equal to H0, that its value at 0 Kelvin 1 minus T by Tc, the whole square. So this will be, it is given 0.3, 1 minus temperature is 2 upon Tc is 4.7, the whole square. After solving this, you will get 0.2456. So rounding off to 3 decimal places, it will be 0.246 Tesla. And the answer range for this question is 0.244 to 0.248. A particle of mass m moves in a lattice along x-axis in a periodic potential V of x is V of x plus d with periodicity d. The corresponding Brillouin zone extends from minus k0 to k0, with these two k points being equivalent. If a weak force F in the x direction is applied to the particle, it starts a periodic motion with time period t. Using the equation of motion F is equal to dp crystal by dt, for a particle moving in the band, where p crystal is the crystal momentum of the particle, the period t is found to be. Now first of all, let us see. We know delta E is equal to integration of f dx, and it is going from 0 to d. So that will be f into d. And we also know by Heisenberg's uncertainty principle, delta E by delta t is greater than h cut. So from here we can write delta t is equal to t. So that will be the time period. So what we are doing is we are considering that interval from 0 to d, and in that interval, since time period is t, time taken will be capital T. So this will be equal to h upon delta E. So that will be equal to h upon ft. So option D is correct. Next question. In a certain two-dimensional lattice, the energy dispersion of the electron is given by this expression, where k bar denotes the wave vector, A is the lattice constant, and T is a constant in units of electron volt. In this lattice, the effective mass tensor Mij of electron calculated at the center of Brillouin zone has this form. Then the value of alpha is. Now Mij, this looks like this. Mij will be, this will be mxx, then it will be mxy, then myx and myy. That matrix will look like this, and we have to find the parts. Now since this mxy, myx are 0, we can calculate mxx plus. Now this is equal to h cut square upon dou 2e by dou kx square, because it is xx. So we will take two derivatives with respect to kx. So let us differentiate this once. So this is the expression we have. So dou e by dou kx. Minus 2t is constant. Then cos kx will be minus of kx into a. So it will be a into sine of kxa plus this 2 into again minus sine of half kxa, and we'll have a by 2 as well. So into a by 2 into we have cos of root 3 by 2 k by a. That will be same thing. So differentiating again. So we can throughout take this minus sign common. So it will be 2t in bracket a sine kxa. This 2 and 2 will cancel out, plus a sine half kxa cos root 3 by 2 k by a. Taking derivative again, dou 2e by dou kx square, it will be equal to 2t in bracket. This will be cos kx a into a square plus this will be a by 2 again, it will come out. So a square by 2 cos of half kx a, then cos of root 3 2 k by a. Now at the center of Brillouin zone, so at the center of Brillouin zone, we have kx is equal to ky is equal to 0. So put kx, ky is equal to 0. So this will be, all these terms will be 1. So this will be 2t, then this will be a square plus a square by 2. And that is 3a square by 2. So 3a square into t. So that will be the first part. And this can, so for the first part, this mxx, this will be h cut square upon 3a square by t, and h cut square upon ta square is taken common. So that means alpha will be 1 by 3, and that will be equal to 0.333. So answer will be 0.333, and the answer range for this question is 0.333 to 0.333. And mxy, if you want to calculate, then that will be h cut square upon dou by dou kx dou by dou ky of e. So that will be mxy. Yx will be, take first y then x, and yy will be dou ky by dou ky. So take double derivative with respect to ky. So answer is 0.333. So these were all the questions from solid state physics part from GATE 2019 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.